Hello and welcome to another Orbital Mechanics video. I'm working through the book Orbital Mechanics for Engineering Students by Howard D. Curtis, 4th edition, and I'm up to problem 2.15 and 2.16. And 2.15 wants us to calculate the period for a satellite in circular Earth orbit, and this satellite has an angular momentum of 60,000 kilometers squared per second. So that is the h equals 60,000 kilometers squared per second. And to get the period, we're just looking at some simple circular maths. So the period equals the circumference over speed, and the circumference is 2 pi r, r being the radius from the center of gravity of the mass divided by the speed. And we can actually get speed by looking at the other equations. V equals mu over h times the square root of 1 plus 2e cos theta plus e squared. Now in a circular orbit, e equals 0, so we just end up with equals mu over h, because that boils down to the square root of 1, which is 1. So we can put this up here, so mu over h, that's our velocity, and r is equal to h squared over, well, in the other equation, r equals h squared over mu 1 plus 2 plus e cos theta. Again, e is 0, so it just becomes h squared over mu. It's very easy. And then if we plug all that in, the period equals 2 pi h cubed over mu squared. I think that's the simplest form. And when you do that out, you get you get the answer that it gives in the book, which is 2.3728 hours. That's that. And then 2.16 is a spacecraft is in circular orbit of Mars at an altitude of 200 kilometers. So altitude equals 200 kilometers. The radius of Mars equals 3.389 3,389 kilometers. And so the radius is that plus the altitude, and the velocity is the Mars gravitational constant, square root of the Mars gravitational constant over r. That comes from another, well, you can get to that by basically plugging h squared. Whenever you put the h, solve for h and put it back in here, you end up with this equation. And then from the velocity, we can get the period quite easily, because divided by 3600 in there. So t equals 2 pi r divided by v, which equals 1.8137 hours. Yeah, and don't forget to divide it by 3600 to get to hours. In the book, it gives 1 hour and 49 minutes, and that is roughly 1 hour 49 minutes for the period, and the velocity came out to be 3.454 meters per second. Slightly different to the book, but we probably had a slightly different constant for Mars. That's that. It's quite easy ones. If you have any questions, leave them in the comments, or if you think I've made a mistake, let me know. Thank you very much. Goodbye.